The geothermal exploration does involve the look for active geothermal regions with the aim of constructing the geothermal power plants. The exploration methods do involve several techniques starting from the drilling process to the geochemical analysis. The geochemical analysis includes the study of relationships between surface fluid properties to geothermal bodies. Geothermometers and other sophisticated instruments are getting used to live the subsurface temperatures. Within the geochemical analysis for geothermal exploration, temperature, the ratios of isotopes, elemental ratios such as mercury and carbon dioxide, etc. are a number of the main measurements being made. In the magnetic method for exploration of heat, identification of the depth of the Curie temperature or Curie temperature is the most vital measurement. Titanamagnetite, which is most ordinarily found in geothermal regions, features a Curie temperature starting from about 200 to 600 degrees Celsius. Most of the geological materials are non-conductors of electricity and thus possess high resistivity, but the structural features can enhance their conductivity. Such transformation in conductivity does facilitate the mapping and thus the composition of the subsurface lithology. The magnetotellurics measurements facilitate the identification of resistivity anomalies related to the geothermal structural features like faults. Such measurements would cause an assessment of geothermal reservoir temperatures at several depths. This method was successfully applied for the detection of heat in several countries and particularly round the Ring of Fireside. The resistivity methods also are being widely want to explore the heat resources. The flowing geothermal waters are the zones of low resistance. The low resistivity zones also can flow from to the variation of the composition of the rocks and thus the temperature. The gravity method is usually want to identify the subsurface density anomalies. Such measurements would be helpful to locate the geothermal regions. The airborne gravitational techniques are more efficient within the collection of knowledge. The gravity data should be corrected for elevation, latitude, etc. The geothermal regions within the subsurface also are the regions of intense seismic activity. These regions are generally characterized by low-magnitude earthquakes. Hence, further studies in such locations might provide clues to the identification of heat sites. The drilling process is one among the foremost expensive but can provide reliable information associated with the subsurface. The geothermal characteristics like thermal pockets, temperature gradients, etc. are obtained by using several sorts of drilling techniques. The newest developments in remote sensing techniques have also been aiding within the exploration of heat resources.